So, how are we going to analyze such games? How are we going to make predictions or prescriptions with such games? Well, one technique that we do use in mathematics is whenever you face a new problem, try to convert it into a problem that you know how to solve, and then solve it. You know, once you convert it to a problem that you know how to solve, you'll solve it using that technique. So we know how to solve, we know how to make predictions or prescriptions for simultaneous move games. That is, games that can be modeled in strategic form. Okay? So what we could do is we could try to convert these problems, these extensive form games, into strategic form. And once we do that, we know how to deal with those. We know how to find dominant strategies, strictly dominant strategies, undominated, Nash, correlated, and all that stuff. Okay? So, but how can we do that? So let's take the game, the simple game that we started with, entry deterrence game. So what did the payoffs, so let me complete the game. Let's write the payoffs, not the payoffs, but the numeric representation of the preferences. So the most preferred outcome for firm 1 was it enters and firm 2 accommodates. So there are 3 outcomes, so let me assign 3 to this. And then the second best was staying out. And the worst one was it enters and firm 2 starts a price war. So that's the worst. The best for player 1, I'm sorry, I got it wrong. So that's player 1. Sorry about that. Okay. So the best one outcome for player 2 was firm 1 staying out, the entrant staying out. That's the best. The second best was firm 1 enters and firm 2 accommodates, the incumbent accommodates. That's better than getting into a price war, because even though getting into a fight, a price war with firm 1 hurts firm 1, it also hurts firm 2. It lowers prices so much that it also loses money. Okay? So that's the game. So we want to predict or prescribe what these players would or should do. Okay? So if it was a strategic form game, if it was a game in which players took actions without knowing the actions that the other players were taking, we could easily make predictions or prescriptions. So what we want to do is convert this into a strategic form game. Okay? And the idea behind the strategic form game is, so tomorrow, firm 1, the CEO of firm 1 and firm 2 are going to play this game. So tonight, each at their home, scratch their head and think what to do. Why wait for tomorrow to make a plan? Okay? So firm 1 plans. When the market opens, I will enter. That's a plan. Firm 1 makes a plan. When the market opens, I'll stay out. Those are the plans that firm 1 can make. Okay? And once he makes the plan, can go to bed comfortably, having already decided what to do tomorrow. What about firm 2? Well, again, firm 2 doesn't have to wait for tomorrow. He can say, well, if firm 1 enters tomorrow, I will accommodate. I will set prices according to the duopoly conditions. That's a plan of action. Okay? And tomorrow, firm 2 will take actions based on that plan. Or firm 1 can say, if firm 1 enters, I'm going to get into a price war. Fight. Okay? That's a plan. And when firm 2 is making this plan, It doesn't have any idea about what plan firm 1 is thinking about, and vice versa. When firm 1 is making a plan saying, tomorrow when the markets open, I'm going to enter. Tomorrow when the markets open, I'm going to stay out. Firm 1 does not have any idea about what firm 2, the CEO of firm 2 is thinking about, and vice versa. So what happened? The game of making plans turned out to be a game in strategic form. Okay? So there are two players, and they make plans. How many plans can firm 1 make? How many different plans of action can firm 1 make? 2, right? Which are? Enter when the market opens, stay out when the market opens. So I can write S1 as enter when the market stay out. Okay. Those are the two plans of actions available to firm 1. Okay. By the way, again, this is too much writing for the taste of a mathematician, so we will write this as E and O. But you have to be careful. The E that I use here is different than the E that I use here. This is the action of entering the market. This is the plan of entering the market when the market opens. This is a plan. That's an action. Okay. Initially, again, when we start the strategic form games, I said, actions and strategies will be synonymous, will mean the same thing for now. Now, they don't mean the same thing. Okay. So a strategy will be a plan of action. I'll tell you what I mean by complete when we start doing a little bit more complicated games. Okay? So a strategy will be a complete plan of action. So when I write E here, this is the plan of entering the market when the market opens. Okay? So let's write the strategies, the complete plans of actions available to firm 2. Well, accommodate if firm 1 enters. Fight if firm 1 enters. Those are the two plans of action available to firm 2, the CEO of firm 2. Okay? So again, this is too much writing, so I will just write A and F. But again, this A, we're abusing language. Like computer science says, we're overloading the meaning of A. Here, A denotes the action of accommodating firm 2. Here, A is the plan of accommodating firm 1, if it enters. Okay? So far, so good? Yep. Mm-hmm. Mm-hmm.
Hence, we must have, for example, OA or OL.
Okay. Yep. Okay. So let's see what happens. So because there's two agents and each agent has two plans of actions, that is two strategies, we can represent this game in a matrix form. Again, not only that, when firm 1 is making a plan of action, it does not know what plan of action firm 2 is thinking about. And when firm 2 is thinking about a plan of action, it does not know
which plan of action firm 1 is thinking about, okay? So given those conditions, we can represent this with this becomes a strategic form game. We can represent it with a matrix. So firm 1, enter when the market opens, stay out when the market opens, accommodate if firm 1 enters. Again, be careful, I don't say accommodate. It's a plan of action. Accommodate if firm 1 enters. Fight if firm 1 enters. So the CEO of firm 1 made a plan of action, decided to use which one? Let's say E. The CEO of firm 2 decided on a plan of action, unaware of the plan of action of the CEO of firm 1. Let's say that chose A. Okay. So what they did was they emailed their plans to the second one in charge, okay, and went playing golf. What would happen? The next morning, the second person in charge of firm 1 and firm 2 will do what? Well, he reads the instruction, says when the market opens, enter. So what action will he take? Enter. What action will the CEO of firm 2 take? Well, what was his plan of action? If firm 1 enters, accommodate. So what happens, the result? Firm 1 enters, firm 2 accommodates. The condition is a duopoly market, which had the numerical representation 3-2. Of course, firm 2 could have, the CEO of firm 2 could have sent the instruction, get into a price war, fight if firm 1 enters. So the second one in charge of firm 2 will do what? Well, we'll see that firm 1 has entered, look at the instruction, and instruction says, if firm 1 enters, fight. And what will happen? There will be a price war. Both firms will be losing money, and their preferences are presented with this number. Okay. Now, if the CEO of firm 1 said, when the market opens, stay out, and the CEO of firm 2 said, if firm 1 enters, accommodate. What will happen? Sorry? 2-3. So firm 1 will stay out of the market, and firm 1 will look at the instruction. If it enters, accommodate. Well, it didn't enter, so it doesn't do anything. So we end up at this point. And the same thing. And that's it. Okay? Any questions? So now we have a strategic form representation of this extensive form game. Okay? This is the game of choosing complete plans of action. This is the game where they choose actions. Okay? But rather than leaving things to the last minute, they think about things beforehand. That's what happens here. Okay? So far, so good? So now I can analyze this game. We know how to study these games. I'll look at the best responses. E is the best response to A. O is the best response of player 1 to F. A is the best response of player 2 to E. Both A and F are best responses to O. So looking at this, player 1 does not have a dominant strategy. Player 2 does not have a strictly dominant strategy, but does have a dominant strategy. And actually, there are 2 Nash solutions. Okay? So the Nash solutions of this game are EA and OF. Okay? So I would predict that one of these 2 will be realized. Okay? Any questions?
Yep.
Are we always able to do this for any extended
Sorry, I couldn't hear again.
Are we always able to convert an extended form game to a strategic form game?
Yes, so the idea is, you see, you can think about what actions you're going to take while playing the game. So firm 2 waits until firm 1 takes an action, or the day before the game starts, you sit down, scratch your head, and think, with each contingency, with each possible situation, what would I do? Okay. It's the same thing. What you do is you think ahead, which is not much what most Turkish people do, but that's how a scientist should do, right? Think ahead. Don't leave things to the last minute. Okay, that's thinking ahead. Okay, any questions? Yes, sir. Which one? Yeah. Okay, so we'll get into that. What was your question?
When we write OF to the net solution of the game,
Uh-huh.
doesn't that imply a second decision taken by the second player after the first player plays no?
Uh-huh. That doesn't what? Can you repeat again?
Implies another decision made by player 2
And-
after player 1 plays no.
Uh-huh. So your friend is saying, so let's look at this strategy profile, this nice solution. Firm 1 plan is to stay out when the market opens. Firm 2's plan of action is fight if firm 1 enters. Okay? So the plan of action of firm 2 is, if this history happens, if this state is realized, fight. Okay? Firm 1's plan of action is, when the market opens, stay out. Okay? So as a result of this Nash solution, what happens? Firm 2 stays out, and firm 1 stays out, and firm 2 doesn't take an action. The game ends. Okay? But so it didn't have to take an action, but it did make a plan. And actually, because of this plan, firm 1 stayed out. So again, here we come to the Nash solution. Okay? If firm 1 believes that firm 2 is going to fight, its best response is to stay out. Okay? If firm 2 believes that firm 1 is going to stay out, okay, its best response is, or a best response is, to, sorry?
The best response would be to do both.
Actually, to fight is a best response. That the plan of using fight when it enters is a best response. And, as your friend said, accommodate is also a best response. Okay? Okay? So, if actually firm 1 decides to stay out, it doesn't matter what action firm 2 takes. But if firm 2 use the plan accommodate if firm 1 enters, then O is not a best response of firm 1. Okay? That's why we don't have OA as a Nash solution. Okay? Okay? So far, so good? Any questions? Any questions? Okay. Now, I'll make a remark about this, and then we'll come back to this game. You see, the CEO of firm 1 gave the instruction of stay out. Okay? And because of that, thinking that firm 2 is going to stay out, firm 1 said fight, or made the threat of I'll fight, made firm 1 believe that he will fight if he enters. Now, if firm 1 entered,
what is rational for firm 2 to do? Okay. If firm 1 entered, so what has happened has happened. Okay. Now, if he accommodates, his payoff is going to be 3. If he fights, his payoff is going to be 1. He prefers accommodating, taking the action A to taking the action F. Okay. So actually, if firm 1 enters, and if firm 2 is rational, what I would expect him to do is to accommodate.
So won't that payoff be 2 instead
Sorry?
won't that payoff be 2 instead of 3?
Okay, well, in that case, we will end up at this Nash solution. But this is still a Nash solution. And why is that? Well, the reason why this is a Nash solution is firm 2 is threatening firm 1 with getting into a price war, okay? But the problem is this threat is not realistic. Okay? So this Nash solution, there's 2 of them, but this Nash solution is a bit iffy. It doesn't look very realistic. Okay? At the outset, so I'll say, if you enter, I'm going to get into price war. Or I say, if you cheat, I'm going to kill you. Well, you know that I won't be able to kill you. It's very costly for me too. But if you cheat, I'm going to take disciplinary action. That threat you will take seriously. The first one, you probably wouldn't. Okay? So this threat is not actually a credible threat. Because once player 1 takes the action, what has been is done. It's now firm 1, 2 has to think again. Well, if I follow the plan of action that I was initially thinking, my payoff is going to be 1. If I don't, it's 2. 2 is better than 1. Okay? So what we have to do is we have to create a new solution concept which will rule out situations like this, which will rule out threats which are not credible, which will rule out situations where at some part of the game the agents behave irrationally. Okay? If at this node player 1 is rational, he should never fight. He should accommodate. Okay? Okay. So this is a branch. This is a strategy profile at which, at this node, player 2 is not behaving rationally. But we based the idea of Nash solution based on rationality. Okay? We said agents will behave rationally. They will maximize their payoffs. Okay? So we need a fix there. And we will do that. But first, let's get a better idea about what strategies are for extensive form games. So let's get a better idea about how to do this transformation. Okay? So let's again work on another simple example, the voting game. And then I'll give a more precise definition of what a strategy is. So, what is the strategy set for player 1? What is the set of complete plans of action that agent 1 can make? Vote for A when it's my turn to vote. Vote for B when it's my turn to vote. Again, it's a plan of action. It's not an action. Okay? So again, we'll abuse notation and write that as A, B, which this A stands for the plan of action, which says vote for A when it's my turn to vote. Vote for B when it's my turn to vote.
What about S2? Sorry? So AA. So let's first do it verbally. Okay. So if if player 1 voted for A, I'll vote for A. If player 1 voted for B, I'll also vote for A. That's a complete plan of action. Okay? If he gives that instruction to somebody else, they would be able to replace him without any problem. Okay? So the shorthand I'm going to use for that is, as your friend did, A, A. I'll use it as a list. Okay? And the convention that we will follow is the first, so first of all, it has to assign actions to nodes at which player 2 has to take an action. So I look at the nodes that player 2 takes an action, and I move from left to right, from top to bottom. So the first A is the action he will take at the leftmost node. The second A is the node which follows it. Okay? So that's a complete plan of action. Another complete plan of action would be AB. Vote for A if A has voted for A. Vote for B if player 1 has voted for B. Another complete plan of action is BA. Vote for B if player 1 has voted for A. Vote for A if player 1 has voted for B. Okay? And the last one, BB. Okay? So those are the plans of actions available to player 2. Okay? So far, so good? What about player 3? It's AA, AB. So what does AA denote?
Player 1 plays A. If player 1 plays A, I will play A.
If player 1 plays A, so that's what player 3 observes. It doesn't observe the action of player 2, so it cannot base its action on the action of player 2. Okay? So he can only base his action on the action of what he can observe, which is the action of player A. So this would stand for the fact that vote for A if player 1 has voted for A. Vote for A if player 1 has voted for B. That is, if I'm in any decision node, any action node, which is in this information set, I'll take the action A. And if I'm any history decision node in which is in this information set, I'll vote for A. Okay? So we cannot say player 3 will take the action A at this history and take the action B at this history, because he does not know whether he's at this history or this history. But he knows whether it's at this information set or is in this information set, which means that he can base his action on which information set he is. And hence, as your friends said, the set of strategy profiles, okay, not profiles, strategies, complete plans of action available to player 3 is A, B, B, A, B, B. Okay? So far, so good? And then based on this, you can write the strategic form game. So far, so good? Okay. So let me give you a more formal definition of a strategy of player I. is a function. A list is also a function. And what is the domain of the function? Is a function. So what is the argument of that function? What do we give as an input to the function? Sorry? Information partition. So the domain is an information partition. So the argument of a strategy is a function that assigns an action to each information set of player I. Okay. So if you remember, in this game, player 1 only had one information set, which was this. Okay. So it was a function, and what are the available actions at that node? The available actions available to player 1 at that node is AB. So a strategy of player 1 is a function from this set to AB. So assign the empty sequence A, assign the empty sequence to B. Player 2 had two information sets. Okay. So the actions available to him was A, B. So it's functions from which assigns this set, this information set, an element, and this information set, an element. Okay. So it could be map both of them to A. That's AA. Map this information set to A, this information set to B. That's AB. And so on. And what about player 3? Well, player 3 also had two information sets. One was the information set consisting of these two histories, and the information set consisting of these two histories. Okay? So player 3 strategy assigns an alternative to this information set, an alternative to this information set. Okay? So far, so good? Okay? So assign both of them to A. Okay? That's AA. Assign to this information set A and to this information set B. That's this. Okay? So far, so good? It's important to get an idea of strategies. Most of the students, it's a very simple idea, but somehow most students get confused about strategies. It's a complete plan of action, which means it's a function which tells us what the agent intends to do at each information set, whether that information set is realized or not. By realized, I mean we end up at a history which is in that information set. Okay? So far, so good? Okay? Let's do some more examples. Let's do the Steckelberg. Zero to alpha. 0 to alpha. What is S1? It's the set 0 to alpha.
Okay. Again, writing a description is always a good idea, okay, where S1 in capital S1 denotes the plan. In which firm 1 will produce S1 units when the game starts. The game starts or the market opens when the game starts. What about S2? So let's give everybody 2 minutes to think about S2. What kind of an animal is S2? Write it down if you have thought about anything. Anybody would like to share? Did you write it? Right. Writing is a good practice. So, what does that mean?
For any possible quantity produce, I have to define what I'll produce.
Okay, so idea is good, the writing is not. Think about it again. So how would you express that in a better way? Have any idea? So what does that mean? So first of all, S1 is a set, right? So you should write it as a set. Anybody? Anybody? Anybody else who would like to share? Good. So Cartesian product. Okay. So then erase these. Okay, but what does the strategy there mean? So take an element from that set, S2 from that set, which will consist of a pair. What does that plan of action tell you?
First element belongs what to act, and the second belongs
What you plan to.
given the player.
Okay, that's good. Anybody else? Share? Okay, but what is that? That's not a set, that's an ordered pair. So you should write it as a set of objects. Okay. Anybody else? Okay, let's take our friends. Well, getting closer to that, but again, that notation is not a good one. You have to learn how to talk the talk, walk the walk. Getting there, you see, that's why writing is important. As you write, you see your mistakes, you see your ideas, but don't write. It's write and then read it and ask yourself, does it make sense? Is it meaningful? Most of the time, you'll just catch your mistakes and you'll learn more. Okay. So, first of all, a strategy of player 2 is a complete plan of action. That is, it's a function, it's a plan which tells us what agent 2 will do at each information set. Okay? So what does the information partition of player 2 consist of? First of all, it's a set, so I'll put my brackets. What does this set consist of? Singletons, right? Because agent 2 knows exactly what has happened, it should only contain a single element. So this is a set which contains of sets of single elements, single histories. By the way, from now on, when I'm writing a history, I'm not going to put these brackets. I'm going to save some ink. Okay, just write it. So a history will consist of a single action of player 1. Okay. So the information partition consists of singletons of the form Q1, where Q1 is what? Is an element from 0 to, well, we said alpha here, alpha, but you can take it to be infinite too, it doesn't matter, okay? So, a strategy of player 2 should be a function which tells us what firm 2 decides to produce. If firm 1 produced 0 units, if firm 1 produced 0.1 units, if firm 1 decided to produce 2.36 units, and so on. Which means that it's a function whose domain is these information sets, which we can represent simply by a number from 0 to alpha, right? And whose ranges 0 to alpha. That's it. Okay. For example, a simple strategy of player 2 could be, actually let me put S2 here. S2 would be, for example, Q1 over 2 for any Q1 in S1. I should write S1 in 0 alpha, not S1, I'm sorry. Okay? Even though mathematically they're the same, interpretation-wise they're different. Okay? For any action alpha, so what does this plan of action say? I'll produce half of what you produced. That's a strategy. I'll produce exactly what you produced. That's a plan. Okay? So far, so good? So far, so good? Okay? Any questions? Any questions? Okay. Now, some of your friends had something like this. By the way, again, when you write this, give an explanation. Okay? What does S2 mean? S2 is the plan which tells firm 2 will produce where S2 and S2 denotes the plan, the strategy at which firm 2 will produce S2 of Q1 units if firm 1 produced Q1 units. Okay? Always write an explanation. It might be clear what this S2 means for you. It might be clear for me. It might not be clear for somebody else. Always give an explanation. Okay? So, some of your friends said, take S2 to be equal to this. Does that work? Does that work? How many say yes? How many say no? How many vote for yes? 1, 2, 3, 4, 5. Are you scratching or are you saying yes?
I proposed this, but I'm not thinking.
Okay. Well, not only you, several people, but yeah, but you changed your mind. Anyhow, how many say no way? Well, there's more yeses than nos, but again, so why would that not work? Yes.
For example, 0, 0 is strategy.
Mm-hmm.
A strategy in S2.
Mm-hmm.
What does that mean?
What does that mean? For somebody who said yes, what does that mean? Yes?
Actually, I thought that the first one meant that interpret it like that, it might work, but when you denote it like
Okay.
this, I guess it doesn't.
So again, so that's again, it's important to, when you said this, your friends, several of you, had some idea in mind. It's always a good idea to write down what it means. So the interpretation that your friend gave is, Q1, Q2 in 0 alpha cross 0 alpha denotes the situation where firm 2 will produce Q2 units when firm 1 produced Q1 units. Okay? Yep? Bless you. Exactly. So you see, this single element tells what firm 2 will do for only this action of firm 1. This is not a complete plan of action. It's a plan of action when firm 1 has produced Q1. Okay? So that's why this will not work. It's getting close there. It has the idea that it should rely on the action of firm 1. But when you write it like that, it just takes one action of firm 1 and gives one action of firm 2. Okay? What we need is, what is firm 2 going to do for in response to any action of firm 1? Okay? That's why this will not work. It's getting close, but not there. That's what we have. Okay? Yes, sir. Okay, again, just like, so your friend said, why not put some rationality restriction on S2? Okay? Again, when we initially started modeling, when we were doing strategic form games, actually the first example where this came up was when we were modeling second prize sale bid auction games. The strategies, when you're constructing strategies, the question you ask is not what they would do. It's what they could do. What plans can they do? Can they use such a plan? Yes, so that's a strategy. Can they use such a plan? Yes, then that's a strategy. Can they use such a plan? No, because if Q1 is equal to alpha, then the amount that firm 2 should produce becomes 2 alpha. It's not in the set. So that's not allowed, not because it's not rational, but because it's not feasible. So again, when you're writing strategies, you have to be careful. The question that you should ask is, what can they do? Not what they would do. That's the question that we will answer once we finish modeling the game. So now we wrote the strategy set of player 1. We wrote the strategy set of player 2. Okay, so we've converted, almost converted the game into a strategic form game. I'm saying almost. Why almost? Well, in strategic form games, we wrote preferences over strategy profiles. Here, preferences are written over actions. So we have over histories. Okay. So once you translate it to strategic form game, preferences should be over strategy profiles, a number and a function. Okay. So we should define a new numerical representation, pi1 prime, for player 1, a new numerical representation for player 2, pi2 prime, which takes S1, S2, and assigns a number to it. What would that be? Unfortunately, time is up. We'll see you next lecture. That's it. Have fun.